Namaskar, my dear friends. Let us talk about voltage translators. So, voltage translators are used in many places. Let us say we have CAN transceiver, okay, like we have CAN transceiver, and then we have lot of like other level shifters is required based on like you have to send your logic signal from one place to another place. So, what happens is if you have a microcontroller, let us say MCU or FPGA, or you have DSP processors, or maybe some ASIC is there, or maybe you have some PLDs devices. So all these can generate, let us say, around 3.3 volt. These days it is going to as low as like around 1.8 volt or 1.2 volt, even 2.5 volt. So all these things are not compatible to your TTL logic levels, which can be like need to be converted to 3.3 volt or maybe 5 volt logic levels. So in that case, what happens is we can send our signal, let us say SPI signal, UART signal, or I2C signal, or like CAN TXRX signals. So all these signals of low level logic voltage can be converted to high level logic voltage, okay, based on the or utilization of level shifters or voltage translators, okay. So we have already explained you this kind of like requirement. However, these level shifters can be of like multiple types, like it can be of open drain type or push pull type or tri-state type or even like open collector type. So open drain and open collector will require pull up resistors. So what we are going to do is we have taken one IC which is max 3373, okay, max 3373. So as you can see, we have the CAN signal coming from like microcontroller. So CAN signal is coming like this, and VDD is, let us say, 3.3 volt here, and VCC is 5 volt here, okay. So the microcontroller CAN TX and CAN RX signal is going to get converted from 3.3 volt logic levels to 5 volt logic level, and this CAN TXD CAN RXD can be sent to your CAN transceiver, and this CAN transceiver will be converting into your CAN high and CAN low. So this is the simplest way we can like make our logic level signal from one level to another level, okay. Now this particular IC which I have used is having like low level logic, that is VL, and high level logic, that is VCC, okay. So in low level logic you have to keep it lower side, and high level logic you have to keep it to higher side, okay. And this is a bidirectional. It means it can auto detect whether it has to like give the logic level logics from left side to right side or right side to left side. It doesn't matter. The one of the most important part of this particular IC is it can work in tri-state mode as well as open drain mode. So tri-state mode, if you want to work it, you have to put this 3-state pin to low. So I have given one provision in the PCB itself. If you want, you can place this resistor and remove this one. Otherwise, by default, I have pulled it up so that it will be working in open drain mode, okay. So this was all about this particular like voltage level translator. And if you want, you have various like designs of this particular, or various options for this particular max 33 series. So we'll see that as well, okay. So this is 2-line IC. Now if you want to have 4-line IC, what you have to do is you can go ahead with 7-8. So max 3378, okay. And this is also in TSSOP package, TSSOP 14 package, okay. So you can have two pairs of signal here and two pairs of output here. The beauty of this particular IC was, I didn't tell you in the first itself, that even in open drain it has internal pull-up resistor. So you don't need to like put extra pull-up resistors additionally. However, I have given for the like simplicity point of view that if you have a open drain output or something like that, you must have output like pull-up resistors connected. However, this IC is having internal pull-up resistor. Now, what we will do is we can go ahead to the product page of this particular IC and try to give you various aspects that is available with this IC. Okay. Similar to that, for other ICs as well, you will be able to utilize the same concept. However, it is better to go ahead and get familiar with at least one IC completely. So we'll go through the data sheet right now and try to understand what are the availabilities that is available. Okay. So once we come to the product page of analog devices, if you search for Max 3373, you will be seeing the best part is it is having 15 kilovolt of or 15 kV of ESD protection inbuilt. So you don't need to use separately any ESD diode. Okay. And it is having 16 Mbps of speed, and it has dual and quad low voltage translators. All right. Then you can see this is the like controller, and this is the IC that is there. So we have VL and VCC. So data is going to get transferred from controller to your VL, and VL is getting like trying to send it to VCC with higher level voltage. Okay. So this was all about this. Now let's get into the data sheet of this. However, before that, let's get into the data sheet. Okay. So in the data sheet, as you can see, we have max 3372 to 3379. So there are this many number of ICs. Okay. Then we have max 3390 to 3393. Okay. Now it has different speeds. So you can see we have 230 kbps, then 8 mbps, then we have 10 mbps and 16 mbps. So there are various like options that is available. Which one you want to use based on the cost and requirement, you can utilize. Application wise, if you see, you can utilize this particular IC for your SPI signal translator, then micro wire signals, I2C signals. We have low voltage ASIC level translator where you need to have 1.8 volt to let us say 3.3 volt, or maybe 1.8 to 5 volt, something like that. We have a smart card readers or cell phone cardless. We have portable POS system. Okay, point of like contact system and all is there. Then we have portable communication devices. We have low cost serial interfaces, just like that we explained you. Then we have cell phones and all other things. Okay. Let us get into the like pin configuration and design. Before that, what we will do is I'll just tell you that if VL and VCC you can see here. So if both the like left side and right side arrows are there, it means you can consider this is a bidirectional device. Okay. And if only one is there, then it will be unidirectional, either left to right or right to left. Okay. So this is how we will be understanding. Good. Absolute maximum rating, if you see, though, then it can take up VCC voltage from like a 0 to around 6 volts. So basically it can be used for your 3.3 volt logic levels or 5 volt logic levels. So these two voltage are more than enough for our utilization. Similar to that, VL, so VL, whatever supply you give, that much plus zero point 0.3 it can take maximum. So this is absolute maximum rating. The beauty is it is in like available in the package of SOT package, which is having a pin outside, and then CF similar to that we have TSSOP package as well. Okay. Rest other package are also there. Now let us get into the electrical characteristics. So VL supply voltage range is 1.2 volt to 5.5 volts. So you can use it for 1.2 volt as well as 1.8 volt, and then 3.3 volt and 5 volt. All other things you can utilize. VCC you can use it to 1.65 to 5.5. Just try to make sure that VCC is always greater than VL. Okay. So whatever circuit you are trying to use, just make sure VCC is greater than VL. Okay. If you talk about SD protection, so SD protection you can see we have IC 61 actually it is. Okay. So 61000-4-2 air gap is plus minus 8 kV, and contact discharge is also plus minus 8 kV. We have HBM model, that is human body model, which is plus minus 15 kV. All right. So hope you have now a good understanding about the particular like electrical characteristics. High level, low level is not needed right now. What I want to show it to you is let's get into the pin configuration and all those things. Okay. Before that, if you want, you can see like how my signal getting transferred, like VOL signal once it goes high, the VCC signal, once it is getting transferred, it is going to go a little bit dragging, you can see. So there is a lag, that much is there, and then it is going to go ahead. So this is how it is working. Okay. All right, so this is what is the pin description. So if you talk about pin description, let us talk about SOT 8 package. Okay, so SOT 23-8 package. So pin number 5, you can see VL are actually input output pins. Okay, then similar to that we have VCC, which is also input voltage. Okay, and VL is in, this is supply voltage, VCC and VL, and IO VCC, IO VLL will be input output your logic labels. Okay, this is the tri-state pin or three-state pin. So three-state pin must be pulled low to make it into push-pull mode, or like a tri-state mode. Okay. Otherwise you keep it high so that it will be in open drain mode. Got it? All right. So basically we have given you two circuits. One is based on SOT 23-8 package, and one more is TSSOP 14 package. Let's get into the application circuit. So what we'll do is we'll try to see application circuit directly. Yes. So typical application circuit, as you can see, we have, let us say, like a data line coming from microcontroller and going to the your system design, or maybe your some transceiver or something. So let us say 1.8 volt to 3.3 volt you want to convert. What you have to do is you have to give a power supply of VL to 1.8 volt logic. Similar to that, you have to give a VCC power supply to 3.3 volt logic, so that the output will become 3.3 volt. Okay, this is the very simplest thing that you can do for any of the voltage translators. Okay. Now, to make sure that your VCC is properly protected and ESD is working fine, what you can do is you can additionally give 1 microfarad capacitance to the power supply pin. Okay, so this is what is the thing. Now let us start with application circuit. So that was typical application that you have to understand. Now if you see, let us say 1.8 volt to 3.3 volt. Basically I have tried using always like 3.3 volt to 5 volt logic. So in that case what you have to do is supply 3.3 volt here and 5 volt here, and in that way you will be able to convert from 3.3 to 5 volt. Okay. Now these two lines are like a bidirectional line. It means you have two data lines which can be either left side to right side or right side to left side. Now if you talk about the output side, so VCC also is same way, like whether it can be like driving the signal or receiving the signal. So both can be possible. So that's the reason what we have done is we have used it for CAN RX, CAN TX. So CAN RX will be like receiving the signal, and CAN TX will be sending the signal. So this is how it can be used for bidirectional purpose. So whenever you see arrows both side, it is working as bidirectional. Okay. And 7.2 is actually 230 kbps, and we have 7.3, that is 8 mbps. Okay. So this is how you have to understand. Let us take another circuit. So another circuit is having 7 4. So if you want to have unidirectional, then you can use this particular device with two data lines. Okay, so it will be only used to send the data from system controller or microcontroller or FPGA to the like voltage level translator, and voltage level translator will give you output to the system, basically like some peripheral device which will be needing to just receive the signal. So it is acting as a host, and this is acting as a client, and just a voltage level translator is happening. Same concept you can utilize. Whatever the voltage level you have to apply here, that much supply you have to give here. Okay. Similar to that, the higher logic level you have to send it. So here you have to supply that much voltage level. So this is unidirectional. Similar to that, there may be a need of like sometimes what happens is one signal I have to send it, one signal I have to receive it, and it has to be unidirectional as well. Okay. So in that case you can use 3375 series. Okay. So one signal will be used as like a receiver, one signal will be used as transmitter. So this is very perfect example for your CAN or like UART signals and all. So CAN signal, one is TX, one is RX. So one line you can use as TX, one line you can use at RX. Now coming back to this, sometimes what happens is, instead of a system to be a host, it has to be a client. So it has to just receive the signal. So to receive the signal, what happens is, you can use 3376 data, and 3376 IC will be just receiving the logic level from higher side and converting into lower side. So this is how you can make use of it. Okay. So you must make sure that VL is lower logic, VCC is higher logic. Now, sometimes what happens is, instead of 2 data lines, we needed 4 data lines. So this is what we have, like utilized in one of our circuit as well, 3378. So this is simply, instead of 2 data lines, we are using 4 data lines. So we have used two ICs. One is Max 3373, which is for 2 lines, and one more is Max 3378 in our various applications for, like this is for 4 lines. And basically everywhere we have, as I told you, like a 3.3 volt to, we have made it to 5 volt. So this is how we have utilized. Similar to 2 lines, you can very quickly now proceed. There is no need to spend time here. So as you can see, for 2 lines, now instead of that we have 4 lines, and this is acting as a host, this is acting as a client, and this will be sending only data from one direction to other direction. So this will be only receiving, it is not, it cannot send this. So in that case, you can use this particular IC so that it can act as a unidirectional. Okay. So if you want to have unidirectional voltage level translator, you can use 3379. Okay. So this is again unidirectional. Let us talk about, like 3 lines are, like going to go as a transmitter, and one is receiver. So this is how it can be used. So there are various, like different options that is there in different ICs. So if you want to have dedicatedly that way, you can do that job. Similar to that, here also we have 2 receiver, 2 transmitter as 3391. And in other devices, if you see, we have 3 receiver and 1 transmitter. So you can see from the controller side, we have 3 receivers. So similar to that, 3 receiving and 1 transmitting. Okay. Similar to that, all the 4 are acting as a receiver. So if you want, you can have a unidirectional device with all the 4 as a receiver signal. So the device that you have to use is MAX 3393. Okay. Now coming to the next part, what we will do is, we'll try to identify how to get very easily the complete part number as well as the speed and all other information about this particular IC. So to know the like exact IC that we want to choose, the package, and like all these things, we can go ahead next. So this is the ordering information. You can see we have the package information, we have the temperature range, and then we have the part number. Okay, so if you want, you can choose accordingly. So basically we have used 3373. So this is the part number we have used, and one more was, we have used 78. Okay, so if you see, we have 78. This package we have used. All right. Good. So this is what we have used, and coming back to the next page, you can see selector guide. So let us say, what is the direction of the selector, whether it is bidirectional or unidirectional. That's the same thing I told you. So we have like how many transmitter, how many receiver are there. So basically, if you have bidirectional, both are transmitter, both are receiver, like that they can work on what is the data rate, what is the top marking that is there. So very nicely you can see that we have like uh, 3373 EEK8T. So this one you can use for your bidirectional purpose for 8 Mbps speed. All right. Similar to that, we have 230 Mbps speed 77, but we have used 78 because it is having 8 Mbps series. So we have used EUD. Okay. So this is how we have used. Good. So you have good information now. Now, if you see about pin configuration or like package and all, so what you can do is, you can use this data. So you can see SOT packaging. So they are bidirectional. We have SOT packaging for 7.4. It is having unidirectional. Similar to that, other directional are there. Then coming back to 7.8, let's come down. Yes, we have 7.8. So this is also bidirectional. Okay. So this is how you can see. So they have given you proper understanding of whether they are, like bidirectional or unidirectional, and how they are connected, how many pins are there. So you can come back to page number 23 or 22 page number, and from there you can see complete packaging information. So basically other people give in the beginning itself, but they have given at the last. Okay. Good. So hope you have a complete understanding of what is voltage translator, how you can use, and what are the different, like options that are available. One is left side, another is right side, like that. So this is how you can, make use of this complete portfolio of this IC. So good. I thank Analog Devices for providing this particular IC for our design, and supporting us in every aspects. So this is how we have, we could use this particular IC in our motor drive application for S32K microcontroller. Okay. All right, guys. Thank you so much.